Dear students, now we are going to see aldol condensation. So two definitions are there, we'll see one by one. So first, aldehydes having alpha hydrogen atom undergoes self-addition in the presence of a dilute base. We are getting the product as aldol. So aldol is the combination of two words, one is ald, another one is OL. So ald no, that is indicating aldehyde, and OL no, that is indicating alcohol. So a second definition is we can take two aldehydes or we can take two ketones that undergoes condensation in the presence of a dilute base. But one condition is there, at least one should have alpha hydrogen atom. That is, for example, we have taken two aldehydes means in that one should have alpha hydrogen atom, or if you have taken two ketones means one should have alpha hydrogen atom, and we are getting the product as beta hydroxy aldehyde or beta hydroxy ketone. This beta hydroxy aldehyde is otherwise called as aldol, and beta hydroxy ketone is otherwise called as ketol. That is, we are using aldehydes means the product would be beta hydroxy aldehyde. If you have taken two ketones means the product would be beta hydroxy ketones. Now we'll see what is an alpha hydrogen atom. So for that we have to take one example, that is this one. So here this is the functional group. So one carbon away from the functional group, no, that is the alpha carbon, that is the carbon which is next to the functional group, no, so that is the alpha carbon, and this is the beta carbon. So the hydrogens connected with the alpha carbon, no, they are called as alpha hydrogens. So these two are the alpha hydrogens. Now we'll see the reaction for this. So here for this we have taken two molecules of acetaldehyde. So first we have taken one acetaldehyde, that is added with one more molecule of acetaldehyde. It undergoes condensation in the presence of a dilute base. So by this addition what happens, the bond between, double bond between the carbon and oxygen, no, so that would be broken. That's why to satisfy the valency of oxygen, this hydrogen is going to add there, and to satisfy the valency of this carbon, so the left group, no, that is attached with that will come and attach with the carbon, and we are getting the product as aldol. So this is the structure of aldol. So what is aldol? When the starting material for that would be acetaldehyde, that's why it is called as aldol or acetaldol. And one more chemical name is, so here hydroxy group is attached with the third carbon, that's why it is 3-hydroxy, and totally it is having 4 carbons, no, 4 carbon alkane is butane, and that butane is having aldehyde. What is the suffix for aldehyde? That is Al, that's why it is called as 3-hydroxy butanol. So what is the name? 3-hydroxy butanol, Al for presence of aldehyde. Instead of writing numbers, we can use alpha beta. So this is the alpha carbon and this is the beta carbon. So beta carbon is connected with hydroxy group. That's why it is called as beta hydroxy butyraldehyde. So that is the another name for this aldol. So what are the other names for aldols? Acetaldol or 3-hydroxy butanol or beta hydroxy butyraldehyde. Now we'll see the mechanism of this aldol condensation. So for this, the first step is the removal of alpha hydrogen atom. For this we have taken one molecule of acetaldehyde that is added with hydroxyl ion. So from where we got that hydroxyl ion? That is from the dilute base. Dilute base is the catalyst for this reaction, that's why from that we are getting this hydroxyl ion. So by the addition of these two, what happens, here this H combines with OH removed as water. So the left thing, no, that is CH2CHO minus. So that would be the product. So that is called as the carbanion, or it can be called as a nucleophile or a enolate ion. And this reaction is a slow reaction, and this is the rate determining step. So now second step is the nucleophilic addition of this carbanion. So now we have taken this carbanion, and that carbanion is added with another molecule of acetaldehyde. So this carbanion attacks the carbonyl carbon of, this is the carbonyl carbon of another unionized aldehyde molecule. So here this nucleophilic carbon, this is the nucleophilic this is the nucleophilic carbon. This carbon atom is going to attack the carbonyl carbon and causing a pi bond break. So this double bond would be cleaved. So because of this breaking, what happens? The migration of pi electrons from carbon to oxygen. So and we are getting the product as alkoxide ion. So what happens here? So this double bond would be broken. So the double bond would be converted to negative charge. That's why we are getting a negative charge here to satisfy the valency of this carbon. So the left group. So here this negative charge would be converted to bond. Bond becomes negative charge here, and here negative charge becomes bond here, and forming a product called as alkoxide ion, and that is an anion. Now third step is the protonation by water. Now we are taking that alkoxide ion, with that we are adding one molecule of water, that is this accepts a proton from the water. Now we are adding water, this accepts a proton from the water, that's why that would be converted to aldol. So this H combines with this oxygen and that would be converted to OH, and we are getting the product as aldol. Already we have known what are the other names. One is acetaldehyde, aldol, otherwise acetaldol, or 3-hydroxybutanol or beta hydroxybutyraldehyde. Now we'll see the salient features of this aldol condensation. It is an irreversible reaction, and this is an addition reaction with or without the elimination of water. And here this aldol, that is eliminating one molecule of water to form an unsaturated compound, that is alpha beta unsaturated compound. So we'll see that. So now we have taken that aldol. On heating, what happens? So here we have OH, that OH combines with H removed as water. That's why to satisfy the valency of these two carbons, here there may be introduction of a double bond, there may be introduction of unsaturation. So and we are getting the product as but2nl, because 4 carbons are there, that's why it is butane, and this is 1 2 3. So bond is between, double bond is between 2 and 3, that's why 2 we have to take first number, that's why but2n, and this is aldehyde, that's why it can be called as but2nl, and its common name is crotonaldehyde. And this is an alpha beta unsaturated carbonyl compound. Why? Because this is the carbonyl group. According to that, this is alpha carbon and this is beta carbon. So unsaturation is present between alpha and beta. That's why it is called as alpha beta unsaturated carbonyl compound. And here this product, the newly formed product, that is having carbon-carbon single bond, that is it is having a new carbon-carbon single bond, and this occurs between the carbon of one aldehyde with the carbonyl carbon of another aldehyde molecule. And this product, that is having two functional groups. Already we have known, that is from the name itself we can say one is the hydroxy group, another one is a carbonyl group. And this is the characteristic for of carbonyl compounds, that is having alpha hydrogen atom. So if it is not having alpha hydrogen atom, it will not undergo this reaction. So examples are formaldehyde, benzaldehyde and benzophenone. So now we are going to see about ketols. Already we have seen about aldols, and we are going to see about ketols. So what are ketols? Ketones having alpha hydrogen atoms can undergo aldol condensation to form the product called as ketols. So for this we have taken acetone, that is a ketone, that is treated with one more molecule of acetone. So both are having alpha hydrogen atoms that undergoes condensation in the presence of a dilute base. So what happens here? The double bond between carbon and oxygen, that would be broken. That's why this hydrogen is added with the oxygen, and the left group is added with the carbon, and we are getting the product as ketol. Ketol. And for this, the starting material is acetone, that's why this can be called as diacetone alcohol. This ketol on dehydration by means of heating, we are getting alpha beta unsaturated compound similar to aldols. That is we are heating that. On heating, this OH and H removed as water, that's why we are getting an alpha beta unsaturated carbonyl compound, and this can be called as mesithyl oxide, or we can write fourth position is connected with methyl, that's why it is called 4-methyl. Totally it is 5 carbons, that's why pentane, and the bond between, double bond between 3 and 4, that's why it is called as 3-pentan 2-one. So that's all about aldol condensation. Thank you.